Okay, students, we will wait for 2 to 3 more minutes. Let some other people join and then we'll start. Okay, let's start then because otherwise we won't be able to complete the syllabus like this. Okay, just a second. Let me share my screen first. And first of all, good morning, everyone. And I hope my audio and screen is visible to everyone. If I can quickly get this. Okay, yes, thank you. Right. Okay. So in the previous class, we had studied the stop and wait ARQ. We had also studied the protocols for the noiseless channels, that is simplest as well as stop and wait. And for the noisy channels, we studied the concept of ARQs, that is automatic repeat request. And there were three protocols. The first one was stop and wait ARQ, the second one is go back N ARQ, and the third one is selective repeat ARQ. And again, whenever we were studying the stop and wait ARQ, we understood the concept of the acknowledgement frames, right? So not only do we have data frames that we are sending from the sender to the receiver side, but again we will have a concept of what acknowledgement frames that will come from the receiver side whenever the receiver will receive the data. And until and unless the acknowledgement frame comes from the receiver side and the sender receives it, the sender will not be able to send the next frame. Okay, so that was stop and wait ARQ. Now the second one is something called as go back N ARQ, right? Now what is go back N? N means the sliding window size here. Okay, now what's the sliding window? We will discuss that later. But again, first and foremost, let us understand some few concepts first. So first is n. N is nothing but the sliding window size. Now, if for example the value of n is 4 that we are seeing in this example, and we say go back n, which means for every error that will occur, error here means what? That suppose I am sending a frame from the sender to the receiver side, and the receiver does not receive the frame, which means the receiver will not send the acknowledgement, or it may happen that the receiver has received the frame, but whenever it has sent the acknowledgement has not received, and acknowledgement was not received by the sender. So in that scenario, what will happen is I will go back. The sender will go back and it will send what? 4 frames that it had already sent previously. Okay, so that is meant by n. Okay, and obviously ARQ means automatic repeat request. Now let us understand the concept first. There is a concept called a sliding window. Now this sliding window concept is very important. Okay, now so if I have a sliding window of size 4, if you see the first diagram, you will be able to understand that if I have a sliding window of size 4, so which means whenever I have a frames, like here I have 11 frames, so starting from a 0 till the 10th, right? So we have 11 frames, and whenever we have a sliding window of 4, we can say that okay, so we will have a sliding window at the frame or at the sender side, and this sliding window, since it is 4, which means in one sliding window or at that time, at the time of the sliding window, we will be able to send 4 frames at the same time. Okay, so which means if at the sender side I am seeing that the sliding window size is 4, and again if I draw a sliding window or draw a window or a contention window of size 4 here, we can see that at the same time I can send what? 0, 1, 2 and 3. Okay, now why do we do this? Because in the case of stop and wait ARQ, we have seen that after sending one frame, it has to wait for the sender to give the acknowledgement, right? Again, after it receives the acknowledgement, it will again have to send only one frame, and after sending that one frame, again the sender will have to wait for an acknowledgement. So this takes a lot of time, and this amount of time is not feasible whenever we are talking about practical communication channels. Okay, now to speed up the process, what we have done is we have given a provision to the network that it can send what? More than one frame at the same amount of time. Okay, so that's the first thing. The second thing is that since we are saying that the sliding window size is 4 at the sender side, we should always remember that in the case of go back n ARQ, the window size at the receiver side is always 1. Okay, so in the case of go back n ARQ, why I am saying go back n ARQ specifically? Because in the case of go back n ARQ only, we will have the sliding window size at the sender side. It can be anything. It can be 4, it can be 5, it can be 6. That will depend on the network that we are using. But the sliding window size at the receiver side will always be equal to 1. Okay, so remember this. Go back in ARQ, sliding window size at the sender side may be anything. It will be determined by the network that we are using. But the sliding window size at the receiver side will always be equal to 1. Okay, now so whenever we are sending suppose 4 data, so 0, 1, 2 and 3, so we will be able to send 4 data at the same amount of time. So at the receiver side, the sliding window will shift by 1. Okay, and now if the sliding window shifts by 1, obviously suppose first and foremost it receives the 0th frame. Okay, so the sliding window will shift to the first frame, which means it wants the first frame, right? If you remember the previous class, it will send an acknowledgement of 1 ACK1, which means it wants the first frame, right? Now again I have sent the first frame, so the sliding window will shift towards the right hand side. It will now expect the second frame. I have already sent the second frame, so the sliding window will shift to the right hand side. It will expect the third frame, and I have already sent the third frame, so again the sliding window at the receiver side will shift to the right hand side, and it will expect what? The fourth frame. Okay, now so let us understand the first two diagrams first, and then we will move forward, and let us and we will imagine that how whenever the sliding window of the receiver shifts to the right, what happens at the sliding window at the sender side. We will see that. Okay. Now, so again in the first diagram, if you see that we have a sliding window of size 4, which means I am able to send 0, 1, 2 and 3, all these 4 frames at the same amount of time. Right. Now, so when the receiver sliding window will be obviously at the 0th frame first. So when it receives the 0th frame, it will send an acknowledgement, right, that it wants to receive what? The first frame, and the slider will shift. Okay, am I clear till this? Am I clear till this? Till this, yes or no? I could not find a better diagram.
Yes,
actually,
sir.
but okay. So when it receives the 0th frame, I have sent the first 4 frames at the same time. But when the receiver, since the sliding window size is only 1, so when it receives the 0th frame, it will slide its window to the right hand side, which means now it expects what? The first frame, right? Now let us come to the second diagram. Now let us see what happens. So when when the sender receives the acknowledgement for the 0th frame, right? So the receiver, after receiving the 0th frame, will slide its window to the right hand side. Okay. After sliding its window to the right hand side, it will send an acknowledgement to the sender. What will be the acknowledgement? It will be ACK1, because that is the acknowledgement for the 0th frame, and 1 means it will now it now expects that the sender will send 1. Okay. So whenever the receiver sends the ACK1 acknowledgement, and whenever the sender receives that acknowledgement, see what happens. So which means for the 0th frame, the sender has received the acknowledgement. So what it will do is, it will again shift its sliding window to the left hand side. Obviously in this case it is the left hand side, so it will shift its window to the left hand side, again by a size of 4, right? So which means if it shifts its window to the left hand side by a size of 4, so now previously it was 0, 1, 2 and 3, so now it will become what? 1, 2, 3 and 4. Okay. Now, so after the receiver receives the first frame as well, so what it will do? It will send an acknowledgement, and what will be the acknowledgement name? It will be ACK2, right? Which means it has received 2, but it has received 1, but now it is expecting what? The second frame. So it will send what? ACK2, and after the sender receives the ACK2, again you will see that it will shift its sliding window to the left hand side by a value of 4, which means previously the sliding window had what data? It had 1, 2, 3 and 4. Now it will have what? 2, 3, 4 and 5. Okay. So that's the first thing. The second thing is that you can see in the first diagram that when the sender shifted its window to the left hand side, which means now the first value in the window is 1, so it will just send 1. It will just send 4, right? Because now it has 4 in the sliding window, right? Previously it had 0, 1, 2 and 3, so it had already sent 0, 1, 2 and 3, right? So which means now when the sender has received the acknowledgement for the 0th frame, which means for the first frame, which means it can shift its window to the left hand side, and obviously whenever it shifts its window to the left hand side, what will happen is one new frame will be added to the window. And what is that frame? In this case it is the frame number 4, right? And obviously whenever this frame number 4 is added to the sliding window at the sender side, it will just send 4. Okay, so that's the first diagram. If you come to the second diagram, after sending 4, it will receive the acknowledgement for the frame 1. Okay, so whenever it receives the acknowledgement for frame number 1, what it will do is it will just shift its window to the left hand side, right? And whenever it shifts its window to the left hand side, the new frame, that is 5, will come into the sliding window. And whenever the new frame 5 comes into the sliding window, what will happen is the sender will just send the frame 5. Okay, like this it will go on. So which means when the receiver sends the acknowledgement for frame number 2, right? So what will happen? The sender sliding window will shift to the left hand side, which means now a new frame 6 will be added, and whenever 6 will be added, it will send the frame 6, right? And similarly, whenever the acknowledgement for frame number 3 will be received by the sender, so what will happen? the sliding window of the sender will shift to the left hand side, and now a new frame, that is the 7th frame, will be added to the sliding window, and the sender can send what? The 7th frame. Okay, am I clear till this? Yes, no?
Yes, sir.
Okay, so kindly ask me if you are not clear, okay, because we are very behind in our syllabus, and I will be trying to finish your syllabus within 3 classes. So this is the first class, and I will take only 2 classes to finish your syllabus. So I will be going a bit fast, and if you don't understand anything, just ask me at the same time, right? Okay, so if this is clear, then let us understand what happens if there is a data corruption or there is a acknowledgement corruption. Okay, now so you can see that in the previous example we have seen that the sender has received the acknowledgement for the 0th frame, for the first frame, right? And after it receives the acknowledgement for the first frame, it will send 5, right? Now the receiver will receive the data receive the frame 2 that the sender has sent initially, right? And after receiving the frame 2, what the receiver will do, it will send an acknowledgement called as ACK3, which means it is the acknowledgement for the frame 2, and now it is expecting what? Frame 3. Okay, now suppose this acknowledgement 3, ACK3, is lost during transmission. Now what happens? Let us understand. Now suppose if this is lost during transmission, what will happen is this sliding window. So obviously the sliding window, what's the principle? That after it receives the acknowledgement for whatever frame, it will just push out that frame from its sliding window, and it will move towards the left hand side, right? Now for the frame 2, the receiver has received it, it has sent the acknowledgement, but the acknowledgement is not received by the sender. So in that scenario, it won't be able to, you know, leave aside 2 and move to the left hand side, right? Since it has not received the acknowledgement for the second frame. Now what will happen? Let us understand. So since it does not receive the acknowledgement for the second frame, right, the sender, what it will think? It will think that okay, I've got the acknowledgement for 0 and 1, which means that is sent, that is fine, and I have not received the acknowledgement for, it can be 2, it can be 3, it can be 4, it can be 5, anything, right? Because those are the frames that are inside my sliding window. Okay, so inside my sliding window there are 4 frames, and I am not receiving an acknowledgement, which means what frames have I sent till now? I have sent 0 and 1. So for 0 and 1 I have received an acknowledgement. Now I have sent 2, 3, 4 and 5, but I have not received an acknowledgement. Now anything can happen, either 2 has not gone, or 3 has not gone, or 4 has not gone, or 5 has not gone, right? So any one of the frames that are inside the sliding window right now might have not gone to the receiver side, and that's the reason why the receiver is not sending me any acknowledgement, right? So in that scenario, what it will do? So if you remember the name, that is go back n, n I said is the actually the sliding window size. Now what's the sliding window size here? It is 4. So what will the sender do? It will go back and it will send what? The 4 frames, all the 4 frames that are there in its sliding window. Okay, so which means, so if you see the second diagram, you can clearly see that since it has not received the acknowledgement for 2, what it is doing is, so what are the frames that are inside its sliding window? It is 2, 3, 4 and 5. It does not know that for which frame the receiver has not sent an acknowledgement, right? So any one of the 4 frames might not have gone to the receiver. So what it will do? It will go back, it will see the number n, that is 4, and it will send all the 4 frames that are inside its sliding window. So again you can see it is sending 2, 3, 4 and 5, all the 4 frames that are inside its sliding window. Okay, and now after, suppose it is sending 2, 3, 4 and 5, the receiver will understand that okay, I have received 2, but again he is sending me 2, which means the acknowledgement for 2 that I have sent to the sender might not have reached the sender. So what it will do? It will reject the second frame, obviously, since it's a duplicate frame, and it will again send an acknowledgement to the sender for the frame number 2. And obviously again, if it receives the acknowledgement for frame number 2, what the sender will do? It will just take out 2 from the sliding window, and it will shift its window to the left hand side, and again it will send what? 6, frame number 6. Am I clear till now?
Yes, sir.
Okay. Now if this is clear, we will move to the next protocol, that is known as selective repeat ARQ. Okay. Now the thing that I said for go back n ARQ is that for the go back n ARQ, the sender side sliding window can be of any size, and that size will be determined by the network. But the sliding window at the receiver side is always equal to 1. Okay, that was the case for go back n ARQ. In the case of selective repeat ARQ, it is not like that. In the case of selective repeat ARQ, what happens is the sliding window size of the sender and the sliding window size of the receiver is the same. Okay. Now, why do we need to go to selective repeat ARQ and not stick with go back n ARQ? Because if you see this disadvantage of go back n ARQ, if you see the previous slide, which means for one frame that may not have gone, or for one frame for which the acknowledgement might not be received, I am sending 4 frames, right? So that is just a wastage of bandwidth, right? Because all the frames that has already been received by the receiver will be rejected, will be discarded, because that's a duplicate frame, right? So we do not want that the frames which I have sent to the receiver and which the receiver has already received, I will send those frames once again to the receiver only for those frames to get rejected by the receiver, because that will result in loss of bandwidth. So we do not want that. So again, we have come up with something called a selective repeat ARQ, and if the name you see, it is a selective repeat, which means for one frame, if the frame has not gone, or if for one frame I have not received the ACK or the acknowledgement, I will only resend that one frame and I will not resend everything. Okay, and that saves a lot of bandwidth. Now we will understand how it is done. Just a second. Okay. Okay. So the first concept is what? That the sender and the receiver sliding window size is the same, right? Which was not the case in the case of go back n ARQ, because in the case of go back n ARQ, the sender sliding window size was something else and the receiver sliding window size was always equal to 1. But in the case of selective repeat ARQ, the sender and the receiver window size will be same, right? That is the first thing. The second thing is, if you see the diagram below, and let us quickly understand what happens. So suppose you see that at the initial time, the sender sliding window size is 4, okay, and the receiver sliding window size is also equal to 4, right? Which means the sender, since it has 0, 1, 2 and 3 in its sliding window, the receiver will also expect what? That the sender, since it has 0, 1, 2 and 3 in its sliding window, he will also send me what? 0, 1, 2 and 3, right? And which means whenever the receiver receives, suppose the first frame, which means the 0, what it will do? It will take out 0 from its sliding window and it will shift its window to the right hand side. So which means now the window will become at the receiver side 1, 2, 3 and 4, right? Similarly, at the sender side, first suppose it is sending 0, 1, 2 and 3, which means if it receives the acknowledgement for the first frame, that is 0, what it will do? It will just take out 0, it will just shift its frame, shift its window to the right hand side, and it will become what? 1, 2, 3 and 4, right? Similar as in the case of if we can see, it's a combination of both go back n ARQ and stop and wait ARQ, right? Now, so suppose at the first instance, what happens is, one more thing, we can see clocks here, right? We can see clocks here, but let me tell you one thing. It might not be clear to you from this diagram, but again, whenever I am starting a clock, right? So I will be starting a clock for the whole sliding window, which means you can see that the 0th clock is not of the same size, but again the first, second, third and first, second and third clocks are of the same size. But in practicality, what happens is that all the clocks are of same size, which means after sending 0, 1, 2 and 3, it will wait till the time the timer for 3 expires, right? So for 1 also it will wait for the timer 3, for 2 for 0 also it will wait for the timer 3, for 1 also it will wait for the timer 3, for 2 also it will wait for the timer 3, and for 3 as well it will wait for the timer 3. Okay, now let us understand what happens. So initially you can see that the sender, since there are 0, 1, 2 and 3 in its sliding window, what it will do is it will send the first frame. Okay, so it will send the frame 0, right? And obviously after sending frame 0, immediately what it will get is the receiver will receive the frame 0, and after receiving the frame 0, what the receiver will do is it will just shift its window to the right hand side, and whenever it shifts its window to the right hand side, it will send an acknowledgement 1, because that is the now ACK 1 means that's the acknowledgement for the frame 0, and now I am expecting that you will send me frame 1. Okay, now so whenever it sends the acknowledgement, what the sliding window sender side will do, it will just shift to the right hand side, right? So obviously since it shifts to the right hand side, now the now it will be able to what, send the first frame. So when it sends the first frame, so let's imagine that the frame 1 is lost. Okay, now so obviously after sending the first frame, what will happen, it can, since 1 2 3 since 1 2 3 and 4 are all in its sliding window, so it can send frame 2, frame 3, frame 4 and so on. Okay, now suppose the frame 1 is lost during transmission. Now obviously the receiver is expecting frame 1, right? It is also expecting frame 2, it is also expecting frame 3, but that is fine. But again, initially it is expecting what, the frame 1. Now if it has not received the frame 1, the receiver, what it will do is, it will not shift its window to the right hand side. Okay, now it will receive frame 2. So okay, frame 2 is in the sliding window of the receiver, so again it will accept frame 2, not an issue. Frame 3 is sent, so again frame 3 is at is in the sliding window of the receiver, so it will accept that. But again, in the sliding window of the receiver, there is also frame 2, which it has not received from the sender. Okay, so again what the receiver will do in that case, it will send something called as a negative acknowledgement, and that is nothing but NAC. So NAC is a new concept that is here in the selective repeat ARQ, right? So there is an ACK. ACK is for whenever the data I have received, and I will be sending an acknowledgement for that. But again, since my sliding window size is 4, and inside this 4 sliding window I have received 3 frames, but I have not received 1 frame, right? So again, to get that 1 frame, I will send what, a negative acknowledgement, right? And what's the negative acknowledgement? It is NAC of 1, which means okay, for all the others I have received, so acknowledgement for that, but the negative acknowledgement is for the first frame, which means I have not received the first frame. Okay, so now whenever this NAC is sent to the sender side, and whenever the sender receives this NAC, what will the sender do? Instead of sending all the things that are inside its sliding window, as in the case with go back NARQ, what it will do, it will receive a negative acknowledgement for only the frame 1. So it will understand, okay, that the receiver has received everything, but it has not received what, frame 1. So what I will do is, I will just resend frame 1. Okay, and after it resends frame 1, you can see that the receiver receives frame 1, and it has now sent an acknowledgement 4, which means I have received everything, and now I will just expect 4. And obviously since the receiver has received 0, 1, 2 and 3 everything, so now you can see that the frame has, the sliding window has shifted to the right hand side, and now it expects what, 4, 5, 6 and 7. Okay, am I clear? Yes, no?
Yes, sir.
Okay, okay, so if this is clear, then we have completed the data link layer, which means we have completed flow control and we have completed error control. Okay, okay, we have time, so what we will do is, we will move into another thing that is called as medium access control, and this is the sub layer inside the data link layer. Okay, so again, whenever we have studied ISO ASI reference model, we have not seen this name, that is medium access control sub layer. So it's a sub layer, which means it is a constituent of the data link layer only. So inside the data link layer, so there's a sub layer called as what, medium multiple access control. Okay, and what is this multiple access control? It means that suppose whenever we are sending data from the sender to the receiver side, okay, so what will happen is, obviously to send the data, we will obviously use the channel in between both the machines, right? So what's the channel? It's a physical medium that we use to send the data actually. Okay, now whenever we want to send the data using these channels, right, now obviously suppose it can happen that there is a bus connection, right, bus topology, if you remember, and to a physical channel, suppose there are 6 computers that are connected. Okay, now suppose if computer 1 is trying to send data to computer 6, and all the other machines are silent, which means they are not sending data, then it's not a problem. Okay, similarly, if computer 2 wants to send data to computer 5, and all the other machines are silent, which means they are not sending data, it's not a problem. But suppose computer 1 and 6 they want to communicate, as well as at the same time computer 2 and 5 also wants to communicate, right? In that scenario, what can happen? So the data that is in between computer 1 and 6 will be there in the channel, right? As well as the data that will be between computer 2 and computer 5, that data will also be in the channel, right? And if both the data are inside the channel at the same time, it can happen that the data may collide and both the data can get damaged, right? Which means if more than two computers are trying to access the medium at the same time, it can happen that the data may get garbled and the data may not receive 5 or 2, as well as the data may not receive not be received by 6 as well as 1. Okay, so obviously we need some mechanism by which we can prevent this data collision, okay, or we can prevent this data garbling. Okay, now these protocols by which we prevent this is known as what? Medium access control, and that is the function of the medium access control sublayer. Okay, now so there are three kinds of protocols that we will study in the case of multiple access protocols, and first one is random access protocol, the second one is control access protocol, third one is what? Channelization protocols. Okay, and again this has been divided into subparts. For the random access protocol we have Aloha. Aloha again can be divided into two parts, pure Aloha and slotted Aloha. Okay, the second one is CSMA, and CSMA has three types. One is a normal CSMA, then we have a CSMA CD, that is CSMA CD is collision detection, and CSMA CA is what? Collision avoidance. Okay, what is CSMA? It is carrier sense multiple access. So again we will see what are these kind of things. Again we have a control access protocol, so we will have reservation, token polling, token passing, these kind of things. And again in the case of channelization, if you remember, in the initial days of networking we have studied the FDM and the TDM and the WDM, right? If you remember. So again FDMA, TDMA are very much similar to FDM and TDM that we have studied earlier. FDM and WDM that we have studied earlier. And in the case of CDMA, and CDMA is a very very famous technology. I hope you have listened or you have heard the term CDMA. CDMA was the technology that Tata Indicom used, Reliance used, MTS used, right? So it was a very famous technology, and it was way faster than the GSM technology that we had then. Okay, so in that scenario GSM was actually in the second generation. It was not 3G did not come out, 4G 5G leave it. Okay, 3G also did not come out, and the data speeds that we got in the case of 2G was in kbps, right? So again in that scenario CDMA came, and CDMA was a very fast technology, and we will see how CDMA works. And after some time, after 3G 4G and now 5G is rolling out, CDMA vanished from existence. So again, but we need to understand that how CDMA actually works. Now we will try and finish some part of Aloha today. Let us see how we can do it. Okay, so for the random access protocols we have four things: Aloha, CSMA, CSMA CD, and CSMA CA. Now so again, what's the random access protocol? Let us understand first. So in random access or contention method, what's the contention we will see, we will understand in the later half of the class. So in random access, no station is superior to the other station. Okay, and none is assigned the control over another. Okay, so why is this happening? Because it may happen that channel computer 1 is actually superior to computer 2. So obviously whenever computer 1 has data to send, it will send the data, and computer 2 will wait, right? It is not like that. So no channel is superior to the other channel, which means if computer 1 has data to send and computer 2 also has data to send, they both can send data at the same time, right? But again, to avoid the collision, we will see what we can do. Okay, so no channel, no station is superior than the other station, and none is assigned the control over the other. Okay, the second point is no station permits, right, another station to send. Okay, so which means, as I said earlier, that suppose the computer 1 has to send data, computer 2 also suppose it has data to send. So if computer 2 sees that okay, computer 1 is sending the data, so I will stop, I will permit computer 1 to send the data. No, it does not happen like that. Whenever the station has data to send, they can send the data, as because no station is superior to the other. Okay. Now at each instance, a station that has to send data uses a procedure defined by the protocol to make a decision whether not to send or whether it has to send. Okay. Now again, as I said, that it will not permit anyone to send the data, but again, whenever the stations want to send the data, they can send, right? But again, that sending or not sending will be determined by what the random access protocols that we will study in this class. Okay. Now, so the first protocol that we will study is known as something called as pure Aloha. Okay. So what is Aloha? Aloha has a full form, but that is not important. So this is nothing but a pure Aloha, which means in the diagram, if you see, suppose we are seeing that the station 1 has 2 frames to send. Okay. So frame 1.1 and frame 1.2. Okay. Station 2, you can see it has 2 frames to send, frame 2.1 and frame 2.2. Okay. Station 3 has 2 frames, frame 3.1, 3.2, and station 4 has 2 frames, frame 4.1 and 4.2. Okay. Now again, you can see that whenever the station 1 has data to send, it will send the data, right? And obviously you can see that the horizontal axis is for the time. So again, if this is the time, so whenever station 1 has data to send with respect to time, so it is sending the data, right? Similarly, whenever station 2 has data to send, it is just sending the data. Station 3 just sending the data, station 4 just sending the data. Now let us see what happens. If you see that at one time, or suppose at a single time, if more than one frame is in the, if I say that the whole thing that we are seeing, the whole diagram is the channel, right? And the channel now has been divided into the time series. So we can see that at one instance of time, if there are more than one frame inside the channel, there will be a collision, right? Which means you can see that at the first collision duration, you can see that frame 1.2, some part of frame 1.2 is there. Okay. Full frame 2.1 is there, some part of frame 3.1 is there, and full frame 4.1 is there. Okay, at the same instance of time. Okay, so which means at this instance, which we are defining as a collision duration, full frame 4.1 will be lost, some part of frame 3.1 will be lost, full frame 2.1 will be lost, and some part of frame 1.2 will be lost. Okay, again we can see the same thing at the right hand side. So again you can see that in this collision duration, we can see that some part of frame 2.2 and some part of frame 4.2 is there at the same time in the channel. Okay, so in that scenario, in this collision duration, what will happen? Some part of frame 2.2 will be lost and some part of frame 4.2 will be lost. Okay, and again you can see that frame 1.1, whenever frame 1.1 is being sent, there are no other frames in this time duration inside the channel, as well as whenever frame 3.2 is sent, you can see that there are no other frames in that time frame in the channel. So again, frame 1.1 and frame 3.2, they will be received by the receiver in full, right? And all the other frames, that is frame 2.1, frame 4.1, will be lost. Frame 1.2, some part will be received, frame 3.1, some part will be received, frame 2.2, some part will be received, and frame 4.2, some part will be received by the receiver side. Okay, am I clear? Am I clear? Is the concept clear? Yes, no?
Yes,
Yes,
sir.
sir.
Okay. Now, so again, what happens in pure Aloha? So okay, let us understand that okay, after the frame 2.1, frame 4.1, frame 1.2, 3.1, 2.2, 4.2, these are not received by the receiver side, right? And only frame 1.1 and 3.2 is fully received by the receiver. What will the receiver do? The receiver will send an acknowledgement for frame 1.1. Okay, it will send an acknowledgement to station 3 for frame 3.2, right? But will the receivers in this case, will they send acknowledgement for frame 1.2? Will they send acknowledgement for frame 2.1, 3.1, 4.1, 2.2, 4.2? It will not, because it has not received the data, right? And it will only send the acknowledgements for frame 1.1 and 3.2. Okay, Now suppose station 1 does not receive the acknowledgement for frame 1.2 and it only receives the acknowledgement for frame 1.1. Okay, so what it will do? It will need to resend frame 1.2. Okay, similarly frame station 2 will also need to resend frame 2.1 and frame 2.2. Station 3 will have to resend frame 3.1 and station 4 will have to resend what? Frame 4.1 as well as 4.2. Okay, now how will they resend it? So whenever the timer, the clock, if you remember the flow control, whenever the clock expires, will it randomly send it? No, right? So that is the case with pure ALOA. When the stations have initially, when they have the data to send, it will send randomly, right? But whenever some data is not acknowledgement for some data is not received by the sender, it will not randomly send the data. So it will follow some procedure by which it will send the data. Okay, now again you can understand that this whole concept is based on a collision, right? Which means if collision occurs, then only I will follow the protocol. That we will study later what is the protocol. But if the collision does not happen, we will just randomly send the data, right? Now suppose if collisions have occurred and now they want to resend the data, let us understand what happens. Now it will follow this algorithm, okay, or this flowchart. Okay, what's the flowchart? Suppose one station has sent a data. So initially they have sent, suppose, a data, right? Now suppose before sending the data, what it will do is it will initiate a counter called as k that will be equal to 0. And what is k in this case? It is number of attempts. Okay, so first and foremost it will initialize the counter k equal to 0. Okay, after initializing the k equal to 0, what it will do is it will send a frame. Okay, and after sending the frame, so obviously I have said that there will be a timer. What's the timer? It will be 2 into 2 TP. Now what is TP? T is nothing but the propagation time. What's the propagation time? It means the time required for a frame to go from the sender to the receiver, right? And the time required for the acknowledgement to come from the receiver to the sender. Okay, so which means if I have a frame time, which means what is frame time? Frame time is nothing but the time required for a frame to go from the sender to the receiver. Okay, so again if we have frame time, so TP will be equal to 2FR. Okay, so if I say that the frame time is TFR and the propagation time is TP, right? So it means TP will be equal to 2TFR, right? Because propagation time is what? Time required to send data from sender to the receiver and the time required to for the acknowledgement to come from the receiver to the sender. So again 2 times of 1 of what? TFR. What is TFR? Time required for the frame to travel from the sender to the receiver. Okay, so what it will do is it will wait for, we will have a propagation time and it will wait for twice the propagation time before receiving an acknowledgement. Okay, so it will give some time for the acknowledgement to actually come to itself. Okay, now after this time it will check whether we have received the acknowledgement or not. If yes, if we have received the acknowledgement, which means the data transfer was or sending the frame was successful, and we will say that it's a success, right? If it has not received the acknowledgement frame, what it will do, let us understand. So what it will do is, since k was the number of attempts, so initially we had k equal to 0, what we will do is we will just increment the value of k by 1. Okay, this algorithm is very important, so again if you don't understand something, ask me. It will just increment the value of k by 1. So now initially suppose the value of k was 0, now it will become what? K equal to 1. Okay, and the maximum number of attempts has been fixed by the network, and suppose we say that the maximum number of attempts a sender can make to send the data is 15. Okay, so again we will check that whether k is greater than k max or not. If it is greater than k max, which means if it is more than 15, what we will do, we will just abort the transmission, which means I will understand that okay, I will not be able to send the data. Okay, my luck is bad, so what I will do, I will just abort my transmission of the data. Okay, that's the first thing. The second thing is, if it is not more than k15, which means I still have some attempts left to retransmit the data. So in that scenario, what I will do is, I will choose a random number r, right, between 0 to 2 to the power k minus 1. So suppose the value of k now is 1, so obviously 2 to the power 1 is 2 and 2 minus 1 is 1. So from 0 to 1, in between 0 and 1, it will choose a random number that is r. Okay, and this r will now determine what something called as a back of time, and it is known as exponential back of time. Why exponential? I will make you understand that. But before that, just see that we have a time tb, and tb is nothing but back of time, and this back of time is calculated by the formula what r is what the number that we have chosen between 0 and 1 in this case. So suppose we have chosen 0.5, so 0.5 into tp. What is tp? The propagation time. Or we can select what r into tfr. What is tfr? That's the frame time. Okay, so we will wait for that amount of time, and again after that we will try and send the frame. Okay, again suppose we are not able to send the frame, so again the value of k will be equal to 2, right? Again, is it more than k max? It is not. So what I will do, I will choose a random number r between 0 and 2 to the power k minus 1. So 2 to the power k in this case is 2 to the power 2, so that is 4. 4 minus 1 is 3. So from 0 to 3 I will choose a random number, and again I will calculate the back of time. Okay, so why did I call it as exponential back of time? So which means again you can see that whenever the value of k increases step by step, that waiting time also will be increasing step by step, right? So that is the reason why we call this as exponential back of time. Okay, so again after waiting for that exponential back of time or back of time, it will just again try and retransmit the frame, and now it will continue doing this until the value of k exceeds 15. Am I clear till now? Yes, no? I am waiting for an answer. Hello? Am I audible?
Yes, sir, you are audible.
Yes, sir. Yes, sir.
Is the concept clear? That is the important. Whether I am audible or not, that is not important.
So can you repeat, sir, this part, sir,
Yes,
TV part? Sir?
yes, that is the thing that I want to hear. Okay,
Sir, it is little bit confusing.
okay. So if you see this diagram, you can see that some frames of some stations are lost, right? They have not been able to send the frame. Okay, so again they will have to resend the frames that has been lost, right? So what will happen? So how will it retransmit the frame? So there is a protocol, there is an algorithm for that how it will retransmit the frame. So what is this? So first we will start. Okay, so suppose for the station 1, suppose it is sending frame 1.2. Okay, initially. Okay, so suppose for frame 1.2 it will start the counter as k equal to 0, right? It will send the frame, that is frame 1.2. It will wait for 2 tp. Now you understand what is tp? Yes, no? Kindly respond because
Yes,
time is very
yes, sir.
less.
Yes, sir.
Okay.
Yes, sir.
Okay, so you understand TP, very good. So it will wait for twice the TP time for getting the acknowledgement. Again, if it receives the acknowledgement, it will be a success. Why? Because if it receives the acknowledgement, which means frame 1.2 has gone to the receiver side and it has received the acknowledgement for the receiver side. Okay, but now suppose the acknowledgement is not received. So again in this case you can see that the acknowledgement will not be received. Why? Because this data has collided with the other datas and it is destroyed. So which means the receiver has not received frame 1.2. Okay, so which means if the receiver has not received frame 1.2, what it will do, it will not send an acknowledgement. Okay, so if the acknowledgement is not received after twice time tp, what we will do is we will just increment the value of k by 1. Okay, so initially the value of k was 0, now it will become 1. Okay, and there will be a limit on how many times we will try and retransmit the data. Okay, so what does it mean? Suppose frame 1.2 I am sending for the first time, I am not able to send it, right? I will send for the second time, I will try for a second time. Again suppose for the second time I am not able to send it, I will try for a third time, I will try for a fourth time, fifth time. But how long will I try? I cannot try for a lifelong amount of time, right? So again there will be a cap on the number of times we will try to retransmit the data. Okay, so again what is the cap? The cap is 15. Okay, so after trying to retransmit the data for the first time, it has failed, so it will just increment the value of k by 1. So k will become 1 in this case, and I will check is the value 1 less than 15? Yes, it is. If it is not, what I will do? I will abort it, because I cannot keep trying for a lifelong amount of time. Okay, so if it is less than 15, that is the cap that has been set. So what I will do? I will choose a random number r, okay, between what? 0 and 2 to the power k minus 1. What is 2 to the power k in this case? It is 2 to the power 1, that is 2. Okay, so result is 2. 2 to the power 1 is 2, and 2 minus 1 is what? 1. So if we choose a random number r between 0 and 1, okay, so suppose we choose it as 0.5, suppose, okay, and after choosing the r bit r as equal to 0.5, what we will do? We will calculate the back of time, TB. Now what is the formula of TB? It is r, that is 0.5 in our case, into TP, that is the propagation time, or it can be what? R into TFR. Okay, so suppose the TP is 1 in this case. Okay, so the value of r is 0.5. So binary back of time will be equal to what? 0.5 into 1, so that is 0.5. Okay, now it will wait for 0.5 amount of time, right, and it will again try and resend the data. Okay, and when it tries to resend the data, if the data is successful, then it's fine. If not, again it will increment the value of k by 1, and again it will try. Am I clear?
Yes, sir.
Yes, sir.
Okay, okay, okay. So it's already 10:21. Your exam is till 10:30. Just go and give your exam. I will stop the sharing first. How do I stop? Yes, stop presenting. Okay, so if you have any problems, remain in the session, ask me the questions. If not, kindly leave and give the IMCRP exam. If you are not able to give the IMCRP exam, come back to the session and tell me. Okay, thank you.